More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home, real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone, welcome back to Mathnasium Schoolhouse. I'm just trying to open up my comments here so I can see everyone. Perfect, that should be good. Awesome. So hopefully a lot of you had joined me yesterday for our part one of our Schoolhouse lesson on angles inside shapes, angles outside shapes, because we will continue with yesterday's lesson. So if you have that document from yesterday, we'll continue with those questions there. Hopefully you tried it out on your own. I had left you with a few questions to ponder on in between the end of yesterday's lesson and the beginning of today's. So I'll be asking you for help on those. Funny to see that someone just finished their Mathnasium lesson. Very good. Yeah, if you have questions on this topic, more than happy to answer it or get my lovely helpers to help me answer the questions. There is also a follow-along worksheet for today's lesson, which is, again, just a continuation of yesterday's, because we will be exploring not just angle relationships as standalones with parallel lines, transversals, and all of that, but how they kind of relate to one another within polygons, within shapes. Are we supposed to follow along while we are doing the lesson? The document is available to you if you would like to follow along. It should be linked in the comments below. And if you find that too distracting, I'm still using the same questions, so you can just follow along with the lesson for the time being and reference the worksheet later. I'll leave it up to you. And as always, if you find that any of these topics that we address here are too complex for you, something that you haven't yet visited in school, seen in school, not a problem. You can choose to listen and see if you can follow along. If not, I highly recommend reaching out to your nearest Mathnasium, and we can really get you started on what the level that you're really at and then work our way up from there so you can eventually tackle topics like these. Is this geometry? Absolutely. It is part of geometry. You would see it as part of a geometry class. And yeah, so hopefully, like I said, you had joined me yesterday. If not, the video is always available for your reference. I'm going to turn to my PDF and whiteboard here so we can get started right away. And we're going to get started with where I left off yesterday. So we're still looking at yesterday's document. And I'm just continuing with question number 10. And for question number 10, we're using this piece of information here. So we have lines T and U, which you can see labeled in our little diagram there. And we know that they're parallel. So the information tells us that these two lines are parallel. And then we have a line that is just intersecting both of them, just kind of going through these two parallel lines. And if I scroll down the PDF just the slightest bit, I'll be able to see that for number 10, I'm being asked to find A. Let me do that here for you guys. I'm asked to find what A is equal to, then B, and then C. So I'll remember that, and let's answer those questions together. I'm just going to scroll back to what we have here. It's kind of a review of what we saw yesterday. How about you guys help me out for question number 10? What is A equal to? Okay. Any of you that tried it out, I'm just going to pull up the comments here. I see 18 appearing. Looks like someone did their homework. Very happy to see that. I agree with 18 from the math that I did. I got 18 as well. Let me just make sure my markers don't roll all over my whiteboard here. How did you get 18? Well, a couple things we can observe, and just to use some of the language some of you might be hearing in your math classrooms, maybe with your Mathnasium work as well, we can work with same side exterior angles here. So if you look at where our A is located in our diagram, you see it right at the bottom there. We have 8A degrees. That's the measurement of that angle there. And what we can do with that is relate it to the 36 degrees because, as I said yesterday, I want to just have one variable in any equation that I'm solving. It makes my life easier. And so why not try to relate that to the 36 degrees that we have over there? And what do I know about it? Well, I know that given the that they're same side exterior angles, I know that they will give me a sum of 180 degrees. All right. And so if I solve for that, I do in fact get 18. All right, perfect. I see some of you are showing me B already, so I'll get to that in just a second. But that is how, for those of you that are asking, how did you get 18? That is how I got it. So after I wrote down this equation, I just solved for it. And again, there are other Schoolhouse lessons available where we focus on solving equations that you might want to reference on how I found A. But really, if I plug in or substitute 18 into my A and I carry it all out, I will get 180. And Echo, I forget your name if you want to share your name. I know you're on your parents' account. I want to give you the credit, but your explanation is perfectly right. If I multiply 8 by 18, I get the 144, which a few of you are sharing as well. Perfect. So that is 18. What about number 11 where we're looking for B? So number 11, we're looking for B. Some of you already shared it already. Here we can use something that we used yesterday, which was when we were talking about the corresponding angles, right? So when we have two parallel lines, for example, going this way and a line crossing them, and we knew, or we're trying to find one of those angles, we can use the relationship of corresponding angles here. So how can we use that here? Well, if we're looking to solve for B, we locate that angle measurement that uses our variable B. So I'm locating it and I see I have a 3B degrees, and I try to relate it to now some piece of information that I know. So whether it's the 36 degrees or the 8 times 18 degrees, because again, I've already solved for A and I'm confident that that's my answer. Okay, and I can go to 3B degrees is equal to 36 degrees. And why is that? Well, because we're going to use, we could do a few things actually, I can say that. So we know that 8A degrees plus 3B degrees is going to give us, they're supplementary to one another, so it's going to give us 180 degrees. So I could just solve it that way, or I can use this relationship here. Either one works. Okay, let's see what you guys are saying here. Okay, so then, oh, you guys are saying B is equal to 12, which is exactly correct if you solve that. All right. And, oh, that's what you guys are asking. I'm confused with the small circle. What is the small circle at the top? Yes, that is the symbol for degrees. I'm sorry if you've never seen that before. Okay, I was wondering, where do you guys see a circle? And then let's solve for number 12 here. We're looking for C. That's the question itself. So as with the previous two, I look for the expression that has my variable C in it. And it looks like it is the 4C minus 12 degrees. And I can use a couple things here. My favorite, I don't know about you, is opposite angles or vertical angles. And so I know that this expression will have to equal my 8A degrees. And so if I solve for that, because I know what 8A is equal to, because I know what A is equal to, if I solve for this, I should get, so let's see if anyone has helped me here. Let's see, what is C equal to? I don't think I saw it just yet. Maybe you guys are solving for it still. But here, if I got it, you can confirm if mine is right or wrong. I got 39. All right. When a number and a letter are next to each other, it means you multiply. Yes, perfect. If anyone was confused by that, thank you for sharing that. Thanks for helping each other out. It's always nice to see. If some of us are confused with some of the notations in math, the language, it's nice that we can help each other out within these lessons. So perfect. So that is all just combining what we had seen yesterday. Let's maybe do one more like this, and then we'll get into the topic of interior angles. So let me just scroll down in this PDF just to the bottom of the second page. So for number 13, which is what we'll be working on together, you're given, and I'll scroll down in just a second, but you're given AE. Here, let me scroll down here. So you can see the line AE. And we want to find three angles here. So we want to find the measurement of angle AFB, and we talked about that notation yesterday, and I'll review in just a second. We want to find the measurement of angle AFD, and then we want to find the measurement of angle BFE. So let's see what we can determine from here, and this is just combining some of that knowledge of supplementary and complementary angles as well. So let's use that knowledge from yesterday to find the first one, which is the measurement of angle AFB. So I'll keep this diagram here for you guys to reference if you don't have it in front of you already. But how can I find that? So I'm looking at the image here, and I first try to find where angle AFB is. And when I locate it, there are two right angles situated there. So one is on top of another. And so when you kind of zoom in with your eyes and see the relationship, angle AFB is complementary to that 70 degrees that we have there. Let's see what you guys are saying here in the comments. Yeah, so there you go. So Tom, for example, is telling us that it is 20 degrees. Perfect. That's exactly right. And hopefully you followed along with my reasoning there. And you know what? I can even write it down here. I did this subtraction in my head because I knew that these two angles were complementary to one another. So rather than erasing that, let's see if we can also find, given the space we have here, the measurement of angle. The next one is actually AFD. Okay. Well, let's locate angle AFD. It looks like we're working with our 90 degrees. So it is the sum of 90 degrees. You can see that right angle there. And whatever angle AFB was, which we found. So if I do that, I get 90 degrees plus 20 degrees, which should give me 110 degrees. I'm not sure if any of you had that here. Yes, I'm seeing 110. Wonderful job. Let me squeeze in the last one here, which is the measurement, and my lovely helper helped explain that to you guys. Yes, when we write M, it means that we're finding the measure of that angle. So the way that I kind of say it out loud is the measurement of this angle. All right. So we want angle BFE again. And maybe I didn't review this in this lesson just yet, but the way that you find this is you can start at B, you go to F, and you end at E, and you find that angle that's contained within each of those. So if I find that, I get, let's see, BFE. Within BFE, I have a 90 degrees, and then I have something. I have the sum of, let's say, BFD plus DFE. Okay? So if I find that, let me maybe even write that out. So if I get BFE, I take the measurement of, what did I say? BFD, which is actually 90 degrees. I'll get us more space in just a second. And I get the measurement of DFE. Let's squeeze that in here. So we'll fill that in just a second. Well, what is BFD? I already said that that's 90 degrees. How do I find the measurement of angle DFE? Well, DFE is actually supplementary to our 90-degree angle, BFD, and our original angle that we found, which was BFA or AFB, whichever way you want to look at it. Okay, and there you go. Just as I finished saying that, I get someone helping me out. DFE is actually 70 degrees. Perfect. So if I add up my 70 degrees plus my 90 degrees, I am going to get my final measurement of BFE. All right. Perfect. I'm going to move on then. Let's start talking about interior angles. This is all a review of the angle relationships that we explored yesterday. And before we answer some of the questions on this worksheet, so I'll leave us with number 14 here just for a second. Let's explore what I left you with yesterday. So let me get my whole whiteboard here. So I asked you to explore what is first of all, the sum. Let's say I have any random triangle. What is the sum of all the angles in a triangle? I'll wait for someone to tell me. What is the sum if I add up all of the measurements of the angles in a triangle? What do I get? We'll need this piece of information. What do we get? So I'll leave that here until I see it. Oh, just as I said that, it came up. Perfect, and it is 180 degrees. So if I add up the sum of A, B, and C here, I will get 180 degrees for any triangle, okay? Now, the other thing that I asked you to explore was what happens when I take different sided polygons. So let's say, and let me just start with a few shapes here. So I'm going to go with triangle. Let's do a rectangle. So 3 sides, 4 sides. Let's do a 5-sided pentagon. We don't have to have them regular for now. And let me try my best to make a 6-sided hexagon here, okay? So my question to you was not just to find the sum of all the angles of a triangle, but now what is the minimum number of triangles that we can divide these shapes into? So if I have a 3-sided shape, which we know to be a triangle, what's the minimum number of triangles that we can divide that into? Well, it's 1, right? It's the triangle itself. So let me write that inside the shapes. Okay? Now, what if I took a 4-sided shape? I just decided it's going to be rectangle. I could have done a square. How can I divide this into the least number of triangles? Okay? One way I can do that, so one easy way I can do it is I could just choose any vertex, any corner, just draw a diagonal, and I have 2 triangles here. Let's write that just beside it. So I've gone from a 3-sided shape to a 4-sided shape. Let's go to a 5-sided shape. And let's use that same way of dividing up the shape. So choose any vertex and start drawing these diagonals. So yes, I could go to the first vertex, but that doesn't create yet a division within my shape. But this does. And how many triangles do I have here? Well, if you count that up, I have 3. You can predict how many I'm going to have in my 6-sided shape while I'm drawing it out. And if you guessed 4, that's correct. And if you continue this, which is hopefully what you tried to do last night after yesterday's lesson, you'll find that this pattern continues. So if I have a 7-sided shape, I'll be able to divide it up into 5 triangles and so on. So let's use that information to guess, make an educated guess, as to what is the sum of the interior angles of an n-sided shape. So I won't even ask that as a question. So the sum of the interior angles. As I'm writing that out, who can help me out here? So because we know how many triangles we can create within these shapes, we can reasonably guess what the sum of the interior angles is equal to, because we know the sum of the angles of a triangle. So if I have, let's say, a square here, and it's composed of 2 triangles, and the sum of these angles is equal to 180 degrees, and so is this, I know the sum of all the angles in here, which would be 360. So if I have an n-sided shape, I get that the sum of the interior angles is equal to however many sides my shape has minus 2 right? Because we always saw the pattern that depending on how many sides in my shape I have, I'll have, how do I say this best? Subtract 2 from that number, and that's how many triangles I have. So if that's how many triangles I have, I can multiply that by 180 degrees, and that is the sum of my interior angles. Okay? So if you understood that reasoning, if I went too fast, you can always go back, pause it, and think about what I said. But if you understand that reasoning, this is the beauty of mathematics, you're actually not memorizing this formula because you understand how we got to it, which was to use our knowledge of the sum of the angles in a triangle and how we can divide up any shape into a minimum number of triangles and find this. Okay? So let's use that to answer some of the questions I had on that PDF. I'm going to go back to my screen here. So let's erase that. What is the sum of the interior angles of a 30gon, okay, which is just a polygon that has 30 sides, okay? Well, we don't have to draw out a shape with 30 sides, first of all, yay, because that would turn out awful, I know. I definitely don't have to start to add up a bunch of 30, maybe less, maybe more angles. And I don't have to draw it out and divide it into triangles because I know the pattern that will come out. So for number 14 here, since we have a shape with 30 sides, I subtract 2 from that because of the pattern I observed, and that'll give me the number of triangles within that shape, and I multiply that by the sum of the angles within each of those triangles, which is 180, and whatever I get here, which, if I did my math correctly in preparation for this lesson, should be 5,040 degrees. And that is the sum of the interior angles of a shape that has 30 sides. All right? Yeah, for those of you that guessed, very, very good. Okay? And so let's jump to number 15 then. Maybe I can squeeze it under here. What is the sum of the interior angles of a nonagon? A shape that has 9 sides. Seems a lot more simpler after we've done number 14, I would hope. So we're just treating it the same way. A shape with 9 sides. To find out how many triangles I can divide it up into, I subtract 2 from that number. That'll give me 7. And I multiply that by 180 degrees. So the number minus 2 times 180 is the interior angles. That's correct, Megan. And I get 1,260 here. It's a lot, huh? A lot of degrees. But it's cool that we could find that without having to draw it out, right? Again, another beautiful thing about math is once you establish a pattern that's going to continue, yes, you have to prove it. We're not at that stage right now, but you definitely could. And once you've proven it, once a mathematician out there has done it, you are free to use it as you wish. So let's jump to the next few questions here. I'm going to scroll down to questions number 16 and 17. So before I show you the whole image, we're looking for angle C in number 16. So I'm going to write that here so we don't forget. Measurement of angle C. And then for number 17, we're going to look at the measurement of angle Q. And now I'll scroll down so you can see it all. So how would we possibly find the measurement of angle C in question number 16? Let me see what you guys are saying. And I'll tell you what I'm thinking, and maybe you guys are on the same page, I hope. Well, I just learned how to find the sum of the interior angles. And since I'm only missing one part, if I know what the whole is supposed to be equal to, remember we kept on talking about wholes and parts yesterday and which one are we looking for. If I know all the other parts and I'm looking for just one part, I can subtract all those other parts from my whole and get my answer. So we won't necessarily do all the math, but let me write out what that looks like here. So if I find the sum of all the angles in this shape and I subtract all those other parts that we know, which is in the diagram there, I can find the missing part C. So without writing too much here, I would find the sum of the shape. So let's first count how many sides it has. 1, 2, 3, 4, 5, 6, 7. So it's a 7-sided shape. Okay. So I'm going to find the sum of all of its interior angles. And I know that that's done by taking how many sides it has, subtracting 2. That gives me how many triangles are there. Multiply that by 180. That's going to be my whole. Let's write that under here. And then subtract all of the other parts. And I don't want to necessarily write all of that. I'll open up a bracket and I'll start to write 128 degrees plus 130 degrees and so on. I'm going to subtract angle B, angle A, angle G, angle F, E, and D. Those are all of the parts. And once I do that, again, supposing that I did my math correct, you should get 124 degrees. So let me write that here on top. You can confirm it. All right. Yeah, and there you go, Christine. I love that you helped us out there with your calculations. So Christine shared with us, before I lose it here, that 7 minus 2, and then all of that multiplied by 180 gives you 900. The rest of them all added up gives you 776, and when you subtract those two, you get 124. Thank you. I appreciate you sharing that. Okay. And how do we find the measurement of angle Q in the next question? That should be fairly simple in the sense that we used our knowledge of the sum of the angles within a triangle to form our equation for finding the sum of all the interior angles. And so this should be as simple as 180 degrees minus 129 degrees minus 28 degrees. We're not working with too much there. Okay? But if you chose to plug it into this formula, you could do that too. It's just that it would be kind of pointless given that you'll just get 1 over here. But you can prove that it works. And for number 17, you should get 23 degrees if you try that out. Yeah, there we go. All right, perfect. Let's move on to numbers 18 and 19, and then we'll look at exterior angles. So the last 2 questions on this page here, let me also see your comments, ask us to find the measure of a regular 18gon, so a shape that has 18 sides. Okay, and we're looking here at a regular. What does regular mean? All of the sides will be equal to each other, but that also means that all of the angle measurements would be equal to each other. So without us having to memorize a formula, how do we logically get to that? Well, we weren't given any numbers in the question apart from how many sides our shape has. Okay? So yes, we know the topic that we're on, which is the sum of the interior angles. So yes, we can kind of, I always say the word cheat, but we're taking what we're looking for and what we know, what we've just learned, and kind of putting those pieces together to try to understand how to find the measure of each angle. Well, logically, if I know the sum of all of the angles within this 18, coincidentally the same number of the question, of this 18-sided shape, can I not just divide that sum by 18 angles that exist within the shape to find the measurement of every angle? And you should say, oh yes, for sure. And the reason we're allowed to do that is because it's a regular polygon, which means all of those angles will be the same. So I don't need to worry about one being smaller or bigger than the other. So using all of that information, we can find 18 minus 2, multiply that by 180 degrees. That gives me the sum. And I can write that out here. So this is the sum. And up to you how you're comfortable seeing this, but you can right away divide by how many angles are within your shape, which is 18. Or you can find that first and then divide it, whatever you're most comfortable with. But this is, again, the number of angles. And when you do that, you should get 160. All right. Yep, Christine, very good. And hopefully I pronounced your name correctly, Kamalakar. So we can do, and you asked the right question. Yes, you are correct. Beautiful. All right, so I'm going to erase this. And let's answer number 19 before we move on to exterior angles as well. So what are we thinking about in number 19? So I want to just keep this here for a few seconds longer for anyone that maybe wasn't following along. Okay, let me erase that now. And let's try to answer number 19 together here. So we're told that each angle of some regular polygon is 60 degrees. We're trying to find out what shape it is. So we know a few things here, right? And you have to look for the key words when you're problem solving in math. Regular polygon, great. Regular to me means, to all of us should mean, as we said before, same lengths of their sides, same measurements of their angles. Okay? So if I know that there is some shape, and I can, draw some sided shape here if I really needed to visualize it. If each angle is 60 degrees, if all of the angles are 60 degrees, what shape would it be? I can do some problem solving, and you guys are already giving me the answer. It is a triangle. I can do some problem solving with the formula that I knew to try to find how many sides are in this shape. So it is a triangle, okay? One way you can confirm that, if maybe you played around with the numbers, is to say, well, 60 degrees plus 60 degrees plus 60 degrees gives me what has to be the sum of the angles in a triangle. Okay, that's one reasonable way to do it. Maybe start off with some sided shapes and play around with the numbers and see if they give you the right sum. And another way you could have done it is actually write out the formula. So we know that it's going to be the sum of the interior angles, and that's found using this information here. And then divide it, again, like we did in number 18, by that number of sides or angles in the shape. And that is supposed to give us 60. Okay. So depending on what you've already seen in the classroom or with a Mathnasium instructor within your learning plan, you can isolate for the variable here. Or if you haven't seen any of that stuff yet in your math just yet, you can just play around with numbers to see what works out such that the left side is equal to the right side. Okay? A few ways you can do this. All right. Perfect. And you guys might have found other ways. Wonderful. So there are some more practice problems on that document. Before we end for today, let's quickly see also, we've talked about interior angles, so angles within a polygon, within a shape. But what happens with the angles all around this shape? And what is an exterior angle anyways? So I'm going to just open up that document. And I'm going to scroll down to the second page. The first page is just a review of what we did yesterday, so you guys are free to look at that. So we're going to use this polygon here, and I'll show you the diagram in just a second. And we're going to look for the measurement of angle V. And before we do that, we need to understand some things about an exterior angle. So whereas before, and I'll just draw us any shape here. Let's say I had this shape. Whereas before we were looking at all of the interior angles, again, that means all of the angles within the shape. The exterior angles of a polygon are those that are formed by extending the sides. So let's say I extended the sides here. Right, and I can just go over all the sides. We have exterior angles that are formed, and we'll use that knowledge in just a second for question number 5 in the second document here. And we're going to use our knowledge of linear pairs of angles that we looked at yesterday to find those measurements. Okay, so it helps to understand what's happening within the polygon to then understand what's happening on the outside. Okay, But you can see, hopefully, that the interior plus the exterior, they're both supplementary to one another. So when you add those up, you will get 180 degrees. Okay. So let's use that information to answer question number 5 here. I'm going to erase this and make sure I can see your comments. This is the last day of angles, yes. So exterior means outside, yes, thank you for that. So let's look at number 5 here. We're being asked for the measurement of angle V. Well, it looks like we have the measurement of the exterior angle of angle V. So how do we find the interior angle V there? Well, we just talked about them being supplementary to one another. So we can find the supplement to 53 degrees, and we get whatever 180 degrees minus 53 degrees is, which I don't see it appearing just yet, so you should get 127 degrees there. Okay. To answer Megan, you would add up 53 and 127 to find that it gives you the sum of 180 degrees, okay? And let's look at number 6. What are we being asked for in number 6 here? We are being asked to find the angle T. Okay, so let's go. So number 6 asks us to find the measurement of angle T. So if I scroll up to my image here, and I look for the T, which is just on the right side there, I have that the exterior angle formed with the angle is 50 degrees. So one more time, I can take my knowledge that they are supplementary, subtract from that the 50 degrees, and confirm that that is 130 degrees. All right? So those should be fairly simple there. Hopefully nothing too crazy. Again, we're working off of knowledge that we took from yesterday's Schoolhouse lesson. Okay. We know the sum of the interior angles, so I'm not going to go through that formula, but we can find the sum of the interior angles for this shape. And how can we do that? Well, reviewing what we've discussed, to find the sum of the interior angles, we need to know how many sides this shape has. So let's scroll up and count 1, 2, 3, 4, 5, 6, 7. So I'm going to use that one more time coincidentally. It's a 7-sided shape for question number 7. Promise that's not on purpose. So we take, let's write it the way that we're used to writing it. So 7, we subtract 2. Again, that gives us how many triangles we can divide this polygon into. Multiply that by 180 degrees. And when you do that, you should get 900 degrees. So that is the sum of the interior angles, which might be able to help us out with number 8. Let's see if that is in fact true. So number 8 asks us to find the measurement of angle S. If I scroll up here, yes. So we're no longer, as opposed to numbers 5 and 6, given the measurement of the exterior angle. So we need to find the measurement of this interior angle. How do we do that? Well, it's as simple as saying, well, we now know the other parts. We know angle R, Q, W. We know angle V. We found it in number 5. We know angle U. We know angle T. We know all those measurements, so we're just looking for the missing part. So maybe that's the way that I'll write it here. And if you take our sum of 900, you subtract all of those other parts, you should get, supposing that I did this correctly, 129 degrees. Okay? And we'll finish off with the last 2 questions on this page. We're not going to draw an exterior angle to Q, but how would we find the exterior angle measurement, which we'll just call X? How would we find that measurement? I'll give you guys a few seconds to help me out with that. Exterior is a little bit confusing to you. Yeah, it might be. It might not be something that you're familiar with, but I promise with just enough practice, you'll get super comfortable with it. It's nothing too crazy out there. But it is kind of odd. I don't disagree in a sense that it's weird to think about angles on the outside, because throughout your whole math career so far, your math life, yeah, you've barely ever worked with exterior. You've only really ever talked about angles within a shape. So it is kind of strange for your mind to start thinking about exterior angles now. And that's fair. We don't talk about it too much. Okay. So we want to draw an exterior angle. We said we're not going to do that, but how can we find the measurement of angle X, which is exterior to Q? So let me scroll up here to see angle Q. Well, we know that angle Q, the interior angle, is 129 degrees. So that means for number 9, it will be whatever 180 degrees minus 129 degrees is equal to, which is 51 degrees. And for number 10, we're being asked to find the exterior angle measurement to angle U. And so very, very similarly, we would take 180 degrees and subtract from that 127 degrees. Okay. So those are the last 2 questions there for the follow along. You can definitely go to the practice problems at the end of this document. Some information that you might be curious to know, which we didn't explore here, is the sum of the exterior angles. Maybe some of you know this. What is the sum of the exterior angles? So I challenge you to explore why this is true, but the sum, and you can investigate it with, again, triangles, 4-sided shapes, 5-sided shapes, 6-sided shapes, and prove it for yourself. But the sum of all of the exterior angles for any convex polygon will always be equal to 360 degrees. And so then, after you've proven that for yourself, what do we do with a regular polygon? Well, we can find that the measurement of every angle in a regular, let's say n-gon, is, and I should say every exterior angle. How about I put that in? So we're talking about exterior angles. Is just going to be the sum divided by how many angles you have. Okay? So it's using the same reasoning as we found these 2 formulas for the interior angles. Just looks a little bit more simpler because the sum here is always just this one number, and this we're just dividing 360, that sum, by how many angles we have. The same reasoning. I am going to end it there for the day. Let me check back on the comments. If you find it confusing, as always, practice makes, and the student actually corrected me on this, whereas I always tend to hear practice makes perfect, the student said to me, practice makes progress. And I love that so much more than perfect, because we shouldn't strive for perfect, we should strive for progress every time. So I'm going to leave you with that. Hopefully you enjoy that as well. Practice with your interior angles, your exterior angles, maybe make some other observations, share, come back to this lesson and share in the comments. I'd love to see it. Have a wonderful weekend. We will see you back at Mathnasium Schoolhouse on Monday. As always, smile loads, try to see the math all around you, appreciate the math all around you, and I will see you next week, and Kevin and John will see you next week as well. Bye-bye, everybody.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.